We're very excited for our next guest, the Vice President and Executive Director of the Virginia Tech Innovation Campus. Please welcome Dr. Lance Collins.
Thank you. Thank you all. Good morning to everybody. It's a pleasure for me to talk about a project that I've been working on for the last 5 years. This is a new campus that's actually opened this January in Alexandria, Virginia. It's away from the main campus, and it's focused on technology. So let me say a little bit more. I'm going to skip that. Oh. There we go. So this is the building that just opened, 300,000 square feet, 11 stories. It was part of the deal to attract Amazon into Northern Virginia. And you can think of it as a kind of bookend we now call National Landing. In the Crystal City, Pentagon City area is Amazon, and we're in North Potomac Yard, kind of on the southern end. We're here to really grow the tech workforce in the region. It was part of the deal to address a workforce shortage in the area. But we're also to serve as a connector. And if you think about what drives technology today, it's really academia, industry, and government. And so really the notion of bringing those things together in this part of the country is really an interesting opportunity. So we just recently announced the academic home for the programming. It's a graduate campus in computer science and computer engineering. And the Institute for Advanced Computing is now that home. These are the research focal areas. You see artificial intelligence, machine learning, next-G wireless, quantum information science, and what we call intelligent interfaces, think HCI. But I want to really focus a little bit more on the AI relevant for this conference. So we have something called the Singani Center, which is really which houses the most sort of deep and technical AI work that goes on the campus. The headquarters are now inside of the building that I just showed you, and it's really focused on a number of technologies, data analytics, forecasting, urban analytics, et cetera. But what's really interesting and important about this campus is that it's really built around partnerships. And so what I'm showing on the right are the industry and federal government partners that this agency, that this center is working with. And that's by design. So the intent here is really to have a sort of deeper level of integration between academia and industry than you would normally find. It has 28 faculty and over 240 students, so it's a large effort, and it really spans just about every dimension of AI that one can think about. So the other interesting element of the campus is the way that we are educating. And in particular, so it's a graduate campus. The degree with the largest number of students by number is Master of Engineering degrees, again, computer science, computer engineering. But what's unusual about it, and I'll say a little bit more about this later in the talk, is that it's a project-based education. And so it's built around students working together on projects, and again, I'll say more about that. There are also more traditional research-type degrees, Master of Science and PhD students, scholars like postdocs, visiting scholars, and so forth. So it really is a truly full-service campus, with the exception that it's focused at the graduate level. Okay, so I want to move on to some of the things that are sort of relevant to the topic we're talking about. And I'm immediately going to expose my age by saying, so how does, when you think about disruptions, that if I go back to my high school years, I'm actually old enough that I was doing calculations, any sort of arithmetic calculations, using logarithm tables and a slide rule. And sort of while I was in high school, electronic calculators showed up. And there was this huge debate. What should we do with this? Is this something we should embrace or not? Because there is a certain knowledge, a certain tactile understanding of arithmetic that comes from actually using logarithmic tables and a slide rule. Will we lose that? Is that compromising? And so, so there was a debate, and it was the outcome was no while I was a high school student, and then it became yes by the time I went to college. So it just shows you that this is not new. But if I go another decade later, then the PC shows up, and the debate rages again, because now you start to take some things that maybe I'm an engineer, so if things that you did with tables, now it becomes a little bit more automated. Then if we add sort of more modern things like the internet and cell phone technology, each of these are disruptors, right? And we have to come to grips. Well, here we are with the latest, which is how should we be thinking about AI in terms of its disruption of the classroom? So there's kind of two ways to think about this, and I in some sense already foreshadowed this when I discussed the log table. One is you forbid it, right? You just say no, you shouldn't use it. The other is that you embrace it. And what I guess the lessons learned from the past is you can try to forbid it for a while, but ultimately it's gonna win the day. So rather than doing that, what I'm going to talk about are two educational experiments, if you like, that we're running that are on the limit to kind of embracing of AI side of things. So the first one is actually, so Narain Ramakrishnan is the guy that directs the Sangani Center, and he's working with an instructor, Margaret Ellis. This is actually a freshman course called Problem Solving in Computer Science. And they redesigned it and said, we want to prepare students to be AI ready and to be able to work collaboratively with AI. So they're very intentional about that. What are the outcomes? They want to demystify, well, what is really an LLM, and really get inside of that and so that students understand it. And they also wanted to design the course in such a way that the students would still get a rigorous education in how to solve problems using computer software. So in very kind of conceptual, simple terms, what they designed were challenges, they called them. And so think of this as on the y-axis, if you get to the top, you've completed the challenge. And then you can think about, but they were free to use their AI. So AI, for example, could be used to perhaps build some of the software. But they were careful to choose problems that the AI couldn't solve, right? So that orange line in the middle is sort of conceptually indicating as far as the AI was able to take them. And then so in order to complete the project, they ultimately had to use their own ingenuity. So human intelligence was there, the fundamentals were preserved because they just monitored to make sure that that top piece was sufficient to accomplish the goals that they had set for the particular problem. So this is just showing a survey of the students' usage of these different tools, and you can see 68% of them use the tools for testing, 52% debugging, 40% code generation, 34% learning and understanding, so they're more of an interactive kind of thing where the AI is in some sense helping, is like a second instructor. Idea generation, 32%, documentation, 20%, and optimization was 8%. What's interesting is that some students really embraced it and used it throughout. Some students actually felt that it was more efficient for them to just code the thing from scratch. Because there's in some ways the AI is fast, but then it's inaccurate. So then you've got to fix it, and you've got to figure out, is the time for fixing it shorter than the time for just writing the code from scratch? And everyone came up with different things. I should also point out, students could select multiple categories, so these numbers don't add up to 100. So it was an interesting experiment, and I think quite successful. And there were some takeaways. So number one, CS is really kind of in the crosshairs here, because these AI tools are really pushing hard on advancing their software capability, because that's the virtuous cycle they're trying to establish to advance AI. So they're ahead of the game, but so CS is serving as, in some ways, the kind of coach for the rest of the campus as they're thinking about how to integrate AI throughout. The second one is that you've got to be agile, because what AI can't do one year may be able to do the next year. So you have to constantly adapt your problem to ensure that you're still achieving the learning outcomes that you want to achieve. And then ultimately, we have to be recognized that we have to constantly be shifting the challenge for students to what we call the higher ground, so that the student continues to develop and grow even as these tools continue to advance. So the second example is one on our campus, which is I mentioned the project-based curriculum. So let me go into that just a little bit further. So our Master of Engineering degree is a 30-credit degree. That's the standard that's out there. Most of these degrees, typically, you take courses, right? You take 10 courses and you complete the degree, a certain number from each category. In our case, we have a very deep, immersive project experience that's embedded inside of the degree. 12 to 15 of the 30 credits are associated with that deep experience. Projects are sourced from outside, so we actually are going to corporations and federal agencies, even K through 12, to identify what the projects are. And then the students are organized to work in teams of 5 to 6. So the idea here is that there's more than just a technical training going on. So what do I mean by that? So I can think about what is AI going to do in terms of these projects? Well, it's going to be helpful in the early stages in terms of ideation. You can actually literally ask it for some ideas. How would you go about solving a particular problem? As I mentioned code development before, it would be useful here as well, and certainly code testing. But there are lots of things that the AI is not going to be very helpful with. So for example, you're organized into a team. You have to learn how to work in a team. That's actually a real life experience, right? And so teamwork is a skill that's the AI is not really going to be particularly useful for. You've got to build those skills on your own. Decision making, so your team may come up with a number of different options, and ultimately you've got to figure out which is the best option to go with. Project management, you manage the deadline, and you have milestones that you have to achieve, and ultimately effectively communicating your outcome to your sponsor. Again, you may get some assistance, but ultimately you're going to be the one that's going to be accountable and responsible for it. So now if we think about careers and where students are going, so the universe of everybody is AI for daily tasks. Everyone is going to be doing that. And so these concentric circles are talking about the degree of specialization. AI for software development, well, almost all software developers these days really take advantage of those tools. So but that's a subset of computer science. And then there's software integration. So now you're talking about bringing together multiple pieces of software to be integrated together. That's yet a smaller subset. And then there's AI customization, and a good example of that would be a TA, right? A sort of chatbot that was a TA for a course in which you're specializing to the particulars of that class. And then ultimately, the most expert people are the ones that are actually advancing these AI tools in the first place. So there's really a spectrum of opportunity for computer science graduates. And then there's the long term, right? So AI is continuing to advance, and there's you can read about the notions of superhuman intelligence. And what does this mean? And my simple way of seeing it is work is going to shift from how, because the how questions will be continually evolving as AI advances, to the what and the why, the sort of higher level questions. What should we be doing and why should we be doing them? What does society need? In some ways, that becomes then the value proposition. And if you don't have those skills, then maybe that's the disadvantage you have. So I'll stop here and summarize. So technology, AI is definitely a disruptor like we've seen before, but it's so pervasive that it's different because it literally touches everything we do at a university, which is unusual. AI tools have been integrated into CS instruction successfully, but you've got to be willing to do the work to constantly update the problems that you're giving the students because the AI is advancing. It provides the opportunity for students to develop what we call durable skills, so the skills that are like the teamwork, the decision making, and so forth, those higher level skills. And the idea is that this project-based learning environment is to push students to the higher ground, the higher level questions, the what and the why. So I'll stop there. Thank you for your attention. So I don't know if that's the time we have left, then maybe I can take a question, or is that fair? Okay, yes? Yes.
I think it's very well positioned. I was curious about your strategy for
So
engaging mid-career professionals, both in terms of upskilling but also career transitioning as the students plus.
the question was, how are we engaging with mid-career professionals? That is a target we are very interested in. I should mention, this is a startup campus, so we literally I was employee number 1 and we've been building. So we really haven't really pivoted to that in a significant way. We've done it with one corporation, but it's very much a goal. It's an extremely important goal for us because we really recognize, particularly these days, recognize the opportunity for people to do some upskilling of their, as all of these tools are constantly changing. Yes. So the question was that I was focused on higher, higher levels of education. But really, post-secondary in general can use these tools. That's why I tried to use the example of even at the freshman level. I honestly believe ultimately these tools are going to be seen in the K through 12 system, and I guess the takeaway I have is that there's a human intelligence that remains the gold standard in certain types of activities. And as AI develops, it's the key at all levels will be getting students to the place where they are advancing the skills that they do best. And the AI is really, in some sense, just the co-pilot on that journey. So that's the tricky thing at all levels. So I think,
Yes, thank you so much. We want to thank our speaker right now. Please, once again, give a warm round of applause to the Vice President and Executive Director of the Virginia Tech Innovation Campus, Dr. Lance Collins.